It's a typical day in a developer's life, writing a complex system or even a not so complex system, and it breaks miserably. You got to debug it. You don't know what went wrong. It's hard to output the right console logs. It's hard to figure out what's happening. If only you had written unit tests. And unit tests sounds like your grandpa warning you to, I don't know, always wear your seatbelt or something like that. But there are 4 reasons, and it should be a part of your development process to always write unit tests for everything, basically at the same time you write it. Sometimes you even want to write the unit test first, especially in the age of AI, where AI can help us with prototype code. You want to write the unit test first so you establish good and bad behavior. But either way, you want unit tests and code to go together. And these are designed to be regression tests where as you make changes and updates to your contracts, as you plug things in, you always are running cargo tests to make sure that all your code still works. So unit tests are incredibly important, and in Rust knows that tests are directly integrated generally into the file with the code that they are testing. You can separate them out, especially as things get a bit unwieldy. You have 30 execute functions in your execute Rust file, and you don't want to have complicated tests for all of them. You'd have a huge file. Sometimes you can separate them out, but generally for smaller things, the tests are right in with the code. So you write a function, you write the test for it. You write a larger function, a multi-part function, you still write the unit test for it. Directly, unlike JavaScript, we don't have to install special frameworks. They're directly included in our Rust files, but they are marked with test, and they're in mod test in a test module at the bottom of the file. Generally, if you spin up the contract CosmWasm template, you will see that those counter functions that are included in the template are tested. Instantiation is tested and an invalid usage is tested, because unit tests should ensure that each piece of your code works correctly. That means spinning up the contract. That means executing the contract, changing things. That means querying the contract. That means migrating the contract if possible. A little harder to test, but it's possible to test with other kinds of tests. And you run through and make sure every bit of your code is tested. If you're interested in ensuring that your project is fully tested, there's even a cargo tool called Tarpaulin, like a tarp. Take just your unit tests and see how much of the code is covered. And that's a useful thing that you can find more about in the lesson and the docs. We won't talk about it here. But just as a default, run cargo tests with every change, major or minor. Not just to make sure that your change works, but that you haven't broken something else. It's usually pretty quick, especially since it doesn't have to recompile the project every time. Test unsuccessful cases as well. This is critical. Your test should even make sure the error is correct, so that you're getting an unauthorized error, not just any end of execution. Otherwise, something else could end execution, the test passes, and you don't notice that the unauthorized error actually should have been thrown and wasn't, for example. So test every good case and generally within reason every bad case, and you'll have this solid code base that you can be confident is maintainable. And as you make changes and add things, you won't get lost in tracking down multi-part bugs and having to maintain more and more spaghetti code, because you've written it cleanly with unit tests. Now, clean code, topic for another day. Should add videos on clean code for sure. But unit testing will actually push you towards some cleaner coding practices as you implement it. Learn is brought to you completely free because of our great sponsors. Neutron, enabling developers to build breakthrough applications and onboard users from anywhere. Osmosis, the premier decentralized crypto exchange. And Obi, the smart new standard for asset management. If you want to become a smart contract developer through this lesson and others like it, head to heretolearn.xyz for uninterrupted course videos, coding exercises, and feedback directly from experts in the industry. Now, unit tests, of course, fake API components. Since we're not working with an actual blockchain, we're not even working with a local simulated network. You can write integration tests for local networks, test nets, and main networks even, but you don't have access to actual blockchain stuff in a unit test, only what we mock and what the contract has. So deps and env will be mocked. There's not an actual block time out there that we're getting or a block height transaction hash, contract address, for example. If I get a contract address in a unit test, it's just going to be something like contract one, not a legitimate contract address, because these elements are all mocked. And I'll show you how to do that. Here is an example unit test. And in this unit test, we import normal things from CosmWasm that we're going to use, like the from binary helper function we use down here. But we also import these mock testing libraries, mock dependencies, mock env, and mock info in our unit tests. Here, we're just using deps and env because we're only doing a query. There's no info with the query, and info is just with executes. But we come into our test, use super just it gives us access to things like the query function and instantiate, things that are in our contract above, right? We're making sure that the functions in the actual file are available within the unit tests. So we mark our tests with the test attribute, otherwise it won't run at all. Even if, we can have other functions in here that aren't tests, helper functions and so on, but cargo test won't know it's a test unless we use this test attribute. Then after spinning up instances of our mocked elements we need, we can call our instantiate function to instantiate our contract. We pass in the deps and the environment. And in this case, I even am using mock info because it's instantiate, which requires info. We can just put whatever we want for the address. Mock info with the sender and empty funds. So we construct a mock info. If you'll recall from the info video, info includes information about the sender and information about funds. Since we're mocking it, doesn't have to be a valid address. It doesn't have to cover the transaction fee or sign the transaction or anything, and its name doesn't have to be a valid Neutron address. It can just be sender, creator, Bob, Pete, Alice, Carol, whatever. Our instantiate message, which we're just passing in empty. So we instantiate this contract. Now, something that you'll see very commonly in unit tests is .unwrap. .unwrap takes a result and unwraps it, and we are sure that it wasn't an error. If it's an error, the test will fail. Otherwise, we just continue. We don't care particularly at all about the response here other than what happens with instantiate, other than that it's a success. So we have a different test to make sure instantiation was successful. So we instantiate our contract, and then we go ahead and send our greet message to our query function. Remember, our query function takes deps, takes env, takes a query message. So we're passing all those in, most of them mocked, but one of them we are constructing inline. This is our query message greet. And then we're unwrapping that to make sure that the query went without an error. Then we take our response. With queries, we always have to convert them from binary because the queries return a binary response. And we unwrap that and get the message element from it. So hello response is a struct with a message member. Then we check that response is equal to hello world. We step through these things. We instantiate our contract with mocks. We query our contract just using the same format, making sure that we put in the same appropriate arguments, whether mocks or whether not. And then we take the response we get and process it and make sure that it's what we expected. In this case, greet returns hello world. This isn't bulletproof. What if this function actually returns a stream of vulgar cursing if you call it at a certain time, right? We don't know that because we haven't tested for that. But generally, this shows us that greet does reply with hello world. So if we did want to test for what happens at certain times, how would we do that? Well, we'd have to modify our env. If you saw in the last video, env, that we can get our block time from env. We have to modify that to fake a current time. This is very appropriate for tests that are testing expirations or vesting or whatever. And you do something like this. You just have a little function that gives you a mock environment, but modifies the block time. Okay, so you can take any block time, which is a U64, you create a new mock environment, and then you set the block time that is in that environment to this new custom block time, and you return that env. And now we don't just get a stock mock env, we get a custom mock env with a block time. So for example, our query returns hello, the time is, and then actually the time just in seconds. It doesn't do any formatting or anything. In that case, we could test it like this. We set a block time. This is approximately the time of this recording. And then we create a custom ENV based on that block time. Now our ENV we're using, it's not ticking up. There's no chain, there's no nodes. If we want it to go up in seconds, we'll have to add manually later. We have that ENV, and when we go through our query instantiate and query and say greet, please greet me, and it returns a message, and we parse the message out just like we did in the last slide. We get the message, hello world, the time is, and then the block time. And so this is testing that the query does in fact return the current block time in its message. So if we wanted to set, vesting times, expiration times, and have tests that expected appropriate results, this is how you do it with a custom ENV. And you can similarly do this with custom info, as we showed. You can set the sender, you can do some custom funds, even though they're not being sent in. Back here when I instantiated, maybe instantiating requires funds. Well, this vector right here, I could just put in there that I'm supplying 10,000 of some coin, and I don't actually have to pay it. I don't actually have to attach it because this is a mock info. So we can test who's sending the transaction, what funds they're sending, what time it is, and anything else, block height, right? Anything else we can think to change in these mocked dependencies, mocked ENV and mocked info, we can do so for the purposes of unit testing. Let's put a pause on it right now. I've tended to let these videos get too long sometimes, and apply this to an exercise right now. TTT tests will walk you through something where you do have to manipulate both the sender and the funds they send and the ENV block time. So you'll have to use the mock info and mock ENV, but modify them a little bit in order for the tests to succeed. Now I'm giving you the contract and also the associated tests. They just don't work quite yet right now. So you'll have to finish them. It's not a whole framework project. It's just correct the tests as they are. Of course, today's day and age, you might be tempted just to feed it into Cursor. Good luck if you do. I really can't stop you, but I encourage you to try it by hand. Try correcting the tests by hand, and you'll be a little bit more proficient at writing unit tests and thus making your code more reliable, more consistent, more maintainable, and just overall cleaner code on your journey to being a CosmWasm smart contract engineer. Remember, if you're not at heretolearn.xyz, go over to heretolearn.xyz where you'll find the CosmWasm book, other resources, other examples, as well as exercises for each and every one of the concepts we cover in this course. See you in the next video.